my dear students. Let's start the session.
Rebouncing of the ball. Rebouncing of the ball. Rebouncing of the ball. Clear up. So a ball of mass m is released. Okay, now a ball of mass m is released from certain height h from the ground. From the ground. Okay, now. So here, see this certain height h from the ground. Focus here. In this case, it is okay, now, falling, freely falling under gravity. It is falling under gravity. Position 1. Okay, now it falls from height h. It falls from height capital H. Clear up. So it reaches the ground, but before touching the ground, before the first rebound, okay, now it reaches the ground, but it is not touching the ground. About to hit the ground. About to hit the ground. This is what? This is the position 2. Position 2. Before first rebound. Before the first rebound. Before the first rebound. Before the first rebound. Clear up. So after first rebound, that is the position 2 dash. After the first rebound. After the first rebound. After the first rebound. Understood? After the first rebound. So here it is hitting when it hit the ground. Before hitting the ground. Before hitting the ground. That is the velocity V2. After hitting the ground. That is the velocity V2 dash. After hitting the ground. V2 dash. Okay, now this is the ground. After first rebound, it reaches to the height h1. It reaches to the height h1. After first rebound, it reaches to the height h1. Okay, now some loss of energy. Here the hitting is what? It is what? Loss of some energy. Coefficient of restitution is not 1. Understood? It is fractional. What is the coefficient of restitution? Coefficient of restitution, that is E. Here E would be fraction. E would be fraction. This would be how much? 0 less than E less than 1. It is in between 1. Not equal to 1 and not equal to 0. Clear up. So now this is the fraction. Fraction can be written as V2 dash is the some fraction of V2. V2 dash is the some fraction of V2. Here, 3 ways of given data. 3 ways of giving data in your competitive exams. Data in your competitive exams. Clear up. Velocity becomes velocity reduced by velocity reduced by 20%. Velocity reduced by 20% after the first rebound. After the first rebound. Clear up. After the first rebound. 20% reduced means how much is remaining? 80% is remaining. Then V2 dash is the 80% of V2. 80% of V2. Clear up. Velocity reduced by 20%. Okay na? After the first rebound, V2 dash equivalents to how much? 0.8 V2. Then 0.8 is the coefficient of restitution. 0.8 is the coefficient of restitution. Restitution. Understood? So here kinetic energy lost by kinetic energy here kinetic energy of the ball lost by kinetic energy of the lost by 36%. Kinetic energy of the ball lost by 36%. What does it mean? After in the first rebound lost by 36 means what? How much is remaining? Kinetic energy, final kinetic energy 2 dash equal to how much? 2 dash equal to how much? 64% of kinetic energy yet to 2. Understood? In that case, what we will get? Half into m into v2 dash square equal to how much? v2 dash square equal to how much? 0.64 into half into m into v2 square. Then we can confidently write v2 dash equal to how much? 0.8 v2. Then 0.8 is the coefficient of restitution. 0.8. Understood? V2 dash equals to E into V2. How it is obtained? Tell me. Yeah, it's a what? This part completed. What is the definition of coefficient of restitution? That we need to discuss. Understood or not? This part is clear or not? This is based on the competitive exams. Okay, now based on competitive exams, previous year questions. That is the reference for this particular content. Clear up? Next. Now, focus here. What is the coefficient of restitution? Coefficient of restitution. E. So this is the ball. Ball coming and hitting the ground. About to hit the ground. This would be V2. Okay, this is before collision. Velocity of the ground equal to 0. Before collision, before first rebound. This is what? Before collision, before first rebound. After first rebound, here also velocity of the ground equal to 0. Clear up? So here you can write before collision. This is before collision. This is what? After collision. Understood? So here, what is the velocity of? నార్మల్ గా మనం ఎలా రాస్తాం చెప్పు, మీరు కన్ఫ్యూజ్ అవ్వకుండా ఉండాలంటే ఇది కోఎఫిషియంట్ ఆఫ్ రెస్టిట్యూషన్. మామూలుగా ఏం చెప్పు, వెలాసిటీ ఆఫ్ ద సపరేషన్. ఓకేనా? న్యూమరేటర్ లో ఆఫ్టర్ కొలిజన్ రావాలి. న్యూమరేటర్ లో ఆఫ్టర్ కొలిజన్, డినామినేటర్ లో బిఫోర్ కొలిజన్ రావాలి. డిఫరెన్స్ బిట్వీన్ వెలాసిటీ ఆఫ్ ద టూ బాడీస్ ఆఫ్టర్ కొలిజన్ ఏమవుతుంది చెప్పు? v2 dash మైనస్ వెలాసిటీ ఆఫ్ ద గ్రౌండ్ అయింది. v2 dash ఆఫ్టర్ కొలిజన్ అయింది v2 dash మైనస్ వెలాసిటీ ఆఫ్ ద గ్రౌండ్. ఇదేమవుతుంది చెప్పు? v2 మైనస్ వెలాసిటీ ఆఫ్ ద గ్రౌండ్ అయింది. v2 మైనస్ వెలాసిటీ ఆఫ్ ద గ్రౌండ్. క్లియరా? అది ఫాలోయింగ్. లేకపోతే ఇలా అయినా రాసుకోవచ్చు. వెలాసిటీ ఆఫ్ ద గ్రౌండ్ మైనస్ v2, వెలాసిటీ ఆఫ్ ద గ్రౌండ్ మైనస్ v2, u1 మైనస్ u2, v2 మైనస్ v1. అర్థమవుతుందా? సో మాడ్యులస్ కాబట్టి ఈక్వల్ టు హౌ మచ్? వెలాసిటీ ఆఫ్ ద గ్రౌండ్ ఈక్వల్ టు హౌ మచ్? 0. వెలాసిటీ ఆఫ్ ద గ్రౌండ్ ఈక్వల్ టు హౌ మచ్? 0. v2 by v2 dash, v2 dash, v2 dash, v2 dash by v2. Then we can confidently say that v2 dash equal to e into v2. v2 dash equal to how much? e into v2. v2 dash equal to how much? e into v2. e into v2. Are you following? అర్థమైందా? v2 dash equal to how much? e into v2. Now apply law of conservation of energy between 1 and 2. Law of conservation of energy between 1 and 2. Completed. Apply law of conservation of energy between 1 and 2. ఇది అర్థమైందా? చూడండి ఇక్కడ అప్లై లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ బిట్వీన్ 1 and 2. ఇది ఒక హాఫ్ అన్ అవర్ 45 minutes క్లాస్ వస్తుంది. భలే ఉంటుంది అసలు. ఓకే చూడండి ఇక్కడ 1 కి 2 కి లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ అప్లై చేయండి. వాట్ ఈస్ ద లా ఆఫ్ కన్జర్వేషన్ ఆఫ్ ఎనర్జీ బిట్వీన్ 1 and 2? టోటల్ ఎనర్జీ ఎట్ పొజిషన్ 1 ఈక్వలెన్స్ టు హౌ మచ్? టోటల్ ఎనర్జీ ఎట్ పొజిషన్ 2. ఎప్పుడు కూడా 1 కి 2 కి అప్లై చేయాలి, తర్వాత 2 డాష్ కి 3 కి అప్లై చేయాలి. అంతేగాని దీనికి 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 అప్లై చేయకూడదు. ఇది గాల్లో ఉన్నంత వరకు ఎనర్జీ సేమ్ ఉంటుంది. అర్థమవుతుందా? ఇది పై నుంచి కింద పడింది, కింద పడక ముందు వరకు ఎనర్జీ సేమ్ ఉంటుంది. పడిన తర్వాత ఇది పరిస్థితి, అప్పుడు ఎనర్జీ మారుతుంది. ఇది కింద నుంచి పైకి పోయి మళ్ళా కిందకి వచ్చేంత వరకు ఎనర్జీ సేమ్ ఉంటుంది. ఇది ఇక్కడ నుంచి పైకి పోయి పైన నుంచి బిఫోర్ హిట్టింగ్ ద గ్రౌండ్ అక్కడ వరకు ఏ పాయింట్ దగ్గరైనా ఎనర్జీ సేమ్ ఉంటుంది. అప్పుడు ఎనర్జీ లాస్ కరెక్ట్గా వేసుకోవాలి. సింపుల్. గాల్లో ఉన్నప్పుడు ఆ పర్టికులర్ గాల్లో హిట్టింగ్ కాకముందు అయినా అయిన తర్వాత అయినా గాల్లో ఉంటుంది కదా, పై నుంచి కింద బిఫోర్ హీటింగ్, ఆఫ్టర్ హీటింగ్ టు బిఫోర్ హీటింగ్, అది గాల్లో ఉంటుంది కదా. గాల్లో ఉన్నంత వరకు ఏ పాయింట్ దగ్గరైనా ఎనర్జీ సేమ్ ఉంటుంది. క్లియరా? హిట్ అయిన తర్వాతది అది వేసుకోకూడదు, బిఫోర్ ఆఫ్టర్ వేసుకోకూడదు పాయింట్స్. ఓకేనా? 1 కి 2 కి కన్జర్వేషన్ ఆఫ్ ఎనర్జీ అప్లై చేస్తే ఏమొస్తుంది? పొటెన్షియల్ ఎనర్జీ ప్లస్ కైనెటిక్ ఎనర్జీ ఈక్వల్ టు here v1 equal to how much? What is the velocity? 0. v3 equal to how much? 0. Okay na? So u1 plus k1 equal to how much? Potential energy plus kinetic energy. What is the potential energy? This is the reference. Here it is how much? Upward azimuth to the positive. Then mg is downward. Mass mg, height is how much? mgh plus kinetic energy 0. u2 equal to potential energy 0 plus half into m into v2 square. v2 equal to how much? Square root of 2gh. v2 equal to how much? square root of 2gh. Square root of 2gh. Clear? So how to get the same by using kinematic equation? Kinematic equation. Apply. This is method 1. Method 1. This is method 2. Method 2. Method 2. Apply kinematic equation between. Apply kinematic equation between. Apply kinematic equation between 1 and 2. Apply kinematic equation between 1 and 2. Then what you will get? Final square minus initial square equal to how much? 2 times of plus g into h. Correct or not? Coming down. Kinematic equation coming down. Acceleration equal to how much? Plus g. Coming down. Acceleration is how much? Plus g. v1 equal to how much? 0. v2 equal to how much? Square root of 2gh. 2gh. Clear or not? Now from here to here, when it is moving, completed. Now what you will get? Apply kinematic equation between 2 dash and 3. 2 dash and 3. 2 dash and 3. This is how much? Here, what people are getting? 2 dash and 3. What is the potential energy at 2 dash? 0. Kinetic energy at 2 dash? M2 dash square. That equal to how much? Potential energy mgh1. Kinetic energy 0. v2 dash equal to how much? v2 dash equal to how much? Square root of 2gh1. Square root of 2gh1. Understood or not? v2 dash square 2 dash and 3. 2 dash and 3. Okay, so here v3 square, final square v2 dash square. This is how much? Minus g. Moving up, that is minus g. h1 v3 equal to 0 there. v2 dash equal to 2gh1. Square root of 2gh1. Clear or not? Now coming to completed. Here to here. Here v2 dash equal to e times of v2. Clear up. e2 dash can be written as square root of 2gh1. That equal to e times of square root of 2gh. Then h1 can be written as e square into capital H. E square into capital H. Here, first rebound. Hn, nth rebound. E power 2n into H. So we can prove it. This is the height of the ball reach. Height of the ball. Okay now. Height of the ball rebounds after the first rebound. This is height of the rebounding height of the ball. Rebounding height of the ball. Rebounding height of the ball after first rebound. This would be after nth rebound. Rebounding height of the ball. Okay now, after first rebound, up to what height it will reach? Clear? Understood? Clear or not? Now, what is the time? What is the time t? How to calculate time t? How to calculate time t? From 1 to 2. From position 1 to 2. From position 1 to 2. Downward, A equal to plus G. A equal to plus G. How to calculate t? Time t. So V equal to U to final equal to how much? Initial plus GT. Initial plus GT. This would be how much? Time T1. Time T1. Understood? V1 equal to how much? 0. Okay. V2 equal to how much? Square root of 2GH. That equal to G into T. T equal to how much? Square root of 2H by G. 2H by G. Understood? 2H by G. Now coming to 2 dash 2. Position 2 dash 2 3. Okay now, A equal to how much? Minus G. A equal to how much? Minus G. Final equal to how much? Final equal to initial upward minus GT1. This is how much? 0. V2 dash equal to how much? GT1 square root of 2GH1. This is 2GH1 equal to G times of T1. T1 equal to how much? Square root of 2H1 by G. 2H1 by G. Are you following? So now tell me, H1 equal to how much? H1 equal to how much? H1, T1 can be written as T1 can be written as T1 can be written as square root of 2 times of E square H by G. E square H by G. Then you can confidently write. You can confidently write E times of square root of 2H by G. That equal to E times of T. T1 equal to how much? E times of T. Okay now. T1 equal to how much? E times of T. Understood? Here to here. Yes. Understood? Now we can write Tn can be written as Tn can be written as E power n into T. E power n into T. Right on up to here. This is the data related to first rebound. After first rebound. So we can continue in the next class. తర్వాత సెకండ్ రీబౌండ్ nth రీబౌండ్ మనం ఏం చేయాలంటే ఒక బాల్ ని రిలీజ్ చేయాలి. కింద పడుతుంది, మళ్ళా పైకి వస్తుంది, మళ్ళా కింద పడుతుంది, మళ్ళా పైకి వస్తుంది, మళ్ళా కింద పడుతుంది, అట్లా పైకి కిందకి కింద కింద అట్లా ఇన్ఫైనైట్ హిట్టింగ్స్. ఓకేనా? ఈ గ్యాప్ లో డిస్టెన్స్ ట్రావెల్డ్ బై ద బాల్ కనుక్కోవాలి. ఫస్ట్ వన్ ఈజ్ వాట్? డిస్టెన్స్ ట్రావెల్డ్ బై ద బాల్. అంటే ఏ నుంచి కింద పడి కింద పడి అట్లా వచ్చింది కదా, ఎంత డిస్టెన్స్? డిస్టెన్స్ ట్రావెల్డ్ బై ద బాల్ కనుక్కోవాలి. తర్వాత టైం టేకెన్ బై ద బాల్ టు ట్రావెల్ ద డిస్టెన్స్ కనుక్కోవాలి. ఫైనల్లీ యావరేజ్ స్పీడ్ కనుక్కోవాలి. దాట్ ఈస్ ద ఎండ్ ఆఫ్ ద డిస్కషన్. క్లియర్? బౌన్సింగ్ ఆఫ్ బాల్. బౌన్సింగ్ ఆఫ్ బాల్ చూడండి, ఇక్కడ మొత్తము ఇన్ఫైనైట్ నెంబర్ ఆఫ్ బౌన్సెస్ కి రాశారు. క్లియరా? ఫస్ట్ చూడండి ఇక్కడ. నౌ వి నీడ్ టు టాక్ అబౌట్ bouncing of the ball. Continuation to the last class. See this. A ball released from height h with initial velocity 0. Okay na? It is released from height h. It is released from capital H it is released from capital H and it touches the ground. This is the position 2. Okay now. So with velocity V2, V2 equal to how much? Square root of 2GH from here to here. H and time would be T. Clear up? This is before first rebound. Before first rebound. Before first rebound. Next, after first rebound. After first rebound. Here, this would be the position 2 dash. So V2 dash. V2 dash equal to how much? E times of V2. Okay now, it reaches up to, it bounces up to height H1. It bounces up to height H1. This would be height H1. Height H1. H1 equal to how much? Here, H1 equals to how much? E square, capital H. Time T1 equal to E into T. E into T. So Hn equal to how much? E power 2n into capital H. Okay na? Tn equal to how much? En equal to how much? E into T. E into T. Understood or not? Okay, this is the bouncing height after nth rebound. Clear up? So here to here, this would be coming back 3 dash. While coming back here to here, velocity would be 0 and it will come up to here. It will come up to here. ఇక్కడ V2 dash ఎలా రాయొచ్చు చెప్పండి? V2 dash can be written as square root of 2G H1. So it is coming up to here 3 to 4. V4 also same, right? Square root of 2G H1. Then V4 equals to V2 dash. V4 equals to V2 dash. This is after first rebound. After first rebound. Before second rebound. Before second rebound. Before second rebound. Understood? Before second rebound. This is what? After first rebound. మొత్తం నీకు గాల్లోనే ఉంది. అప్పుడు ఇక్కడ వెలాసిటీ సేమ్ ఉంటుంది. ఇక్కడ నుంచి వెలాసిటీ డిక్రీజ్ అయితే పోద్ది, ఇక్కడ నుంచి ఇక్కడికి వెలాసిటీ ఇంక్రీజ్ అయితే వస్తుంది. అర్థమవుతుందా? సో ఇక్కడ ఇంకా టచ్ కాలేదు కదా, అందుకని ఇక్కడ నుంచి ఇక్కడికి ఏ పాయింట్ దగ్గరైనా ఎనర్జీ సేమ్ ఉంటుంది, టోటల్ ఎనర్జీ సేమ్ ఉంటుంది. క్లియర్? దిస్ వుడ్ బి V4 తర్వాత after second rebound. After second rebound, this would be 4 dash. V4 dash equal to how much? V4 dash equal to how much? E times of V4. Correct or not? E times of V4. Then it will go up to height H. This is how much? After second rebound, it rebounces up to height H2. H2 equal to how much? E power 4, capital H. T2 equal to how much? E square T. So it will go up to 5 and then 5 dash. This is 5 dash. It will come up to here. This is 6. Here it is how much? 6 dash. It will go up to here. This is 7 dash up to here. This would be 8. Here, this is after second rebound, before third rebound. before third rebound, before third rebound, after third rebound, after third rebound. This is before fourth rebound, before fourth rebound, rebound, clear up. So here after, this would be H2, this is H2 time T2, then this is H3 time T3, here H3 time T3. Okay, so here all velocity is 0. Position 1, V1 0, V3 0, V3 dash 0, V5 0, V5 dash 0, V7 0, V7 dash 0. Clear up? Okay, before third rebound, this is V6. After, this is V6 dash, V6 dash. Next, it will come up to here. This is 8. V8. Understood or not? Here, V2 dash equal to how much? E into V4. E4 dash equal to how much? ఇక్కడ before, this is after, before రెండు వెలాసిటీస్ సేమ్ ఉంటాయి. క్లియర్? సో ఇక్కడ మీకు ఏమొస్తుంది? V4 dash equal to V6 వస్తుంది. అర్థమవుతుందా? తర్వాత here after, before V6 dash equal to V8. V6 dash equal to how much? E times of E6. E times of E6. So ఇక్కడ V6 equal to how much? E times of E4. ఓకేనా? సో ఇప్పుడు నువ్వు ఒకవేళ ఆఫ్టర్ థర్డ్ రీబౌండ్ వెలాసిటీ అడిగాడు అనుకో, ఆఫ్టర్ థర్డ్ రీబౌండ్ వెలాసిటీ అడిగాడు అనుకో, సింపుల్. ఆఫ్టర్ థర్డ్ రీబౌండ్ వెలాసిటీ అంటే ఆఫ్టర్ థర్డ్ రీబౌండ్ హైట్ ఎంత అవుతుంది చెప్పు? ఆఫ్టర్ థర్డ్ రీబౌండ్ హైట్ ఎంత అవుతుంది చెప్పు? E power 6 into h. దీన్ని ఎలా రాయొచ్చు? ఆఫ్టర్ థర్డ్ రీబౌండ్ వెలాసిటీ ఎంత? V6 dash square by 2g. V6 dash square by 2g. క్లియరా? సో అప్పుడు ఎలా రాయొచ్చు? 2gh square root of E cube, that is the V6 dash. That is the V6 dash. మామూలుగా V6 dash ఇక్కడ ఎలా కనుక్కుంటావు చెప్పు? E6 dash equal to how much? E6 dash equal to how much? E times of E4. E times of E4. So V4 ప్లేస్ లో ఏం రాయొచ్చు? V4 ప్లేస్ లో ఏం రాయొచ్చు? ఇక్కడ V4 dash. కరెక్టా? V6 equal to how much? Before, after, before. ఈ రెండు సేమ్ కదా? ఆఫ్టర్, బిఫోర్ ఈ రెండు సేమ్. ఆఫ్టర్, బిఫోర్ రెండు సేమ్. V6 equal to how much? V4 dash. V6 dash. Okay. V6 dash equal to how much? V6 dash equal to how much? Sorry. ఇక్కడ ఆఫ్టర్, బిఫోర్. బిఫోర్ థర్డ్ రీబౌండ్, ఆఫ్టర్ థర్డ్ రీబౌండ్. ఆఫ్టర్ థర్డ్ రీబౌండ్ ఏమవుతుంది? E into V6. V6 equal to how much? V4 dash. ఓకేనా? V6 equal to how much? V4 dash. V4 dash equal to how much? E into V4. V into V4. V4 equal to how much? V4 equal to how much? ఇక్కడ ఆఫ్టర్, బిఫోర్. V4 equal to how much? V2 dash. E square into V2 dash. V2 dash. V2 dash equal to how much? E V2. Okay, na? That equal to how much? E square equal to E into V2. That equal to how much? V cube into E V2. V6 dash equal to here. V6 dash equal to how much? E cube. E cube. V2 equal to how much? Square root of 2GH. Square root of 2GH. Are you getting the same? Understood or not? Understood or not? Yes, sir. Clear? Up to where it is clear? అర్థమవుతుందా ఇది? అర్థమవుతుందా? నెక్స్ట్ ఇప్పుడు మనము టోటల్ డిస్టెన్స్ ట్రావెల్డ్ బై ద బాల్ ఇన్ ది ఎంటైర్ జర్నీ that we need to calculate. Average speed of the ball. Calculations in bouncing of ball cases. Completed. Here, write down. Write down. Write down. Total distance traveled by the ball. What is the total distance traveled by the ball? Here, you can put heading. Total distance. Total distance. Total distance traveled by the ball. Total distance traveled by the ball. Total distance traveled by the ball. Yes, total equal to total distance traveled by the ball. Yes, total equivalence to. Yes, total ఎలా వస్తుంది చెప్పండి. ఫస్ట్ క్యాపిటల్ హెచ్ వస్తుంది. ఫస్ట్ ఏమొస్తుంది? క్యాపిటల్ హెచ్ వస్తుంది. తర్వాత క్యాపిటల్ హెచ్ ప్లస్ తర్వాత కింద నుంచి పైకి h1 మళ్ళా పై నుంచి కిందకి ఇంకొక h1. అప్పుడు రెండింటిని యాడ్ చేస్తే ఏమొచ్చింది? 2 times of h1. ఓకేనా? ఆఫ్టర్ దట్ వాట్ విల్ గెట్? పైకి పోతే h2 మళ్ళా కిందకి వస్తే h2. 2 times of h2. 2 times of h3 and so on up to infinity. And so on up to infinity. So okay, what we will get here? Capital H plus 2 times of e power 1h. 2 times of e square. Sorry. E square h. 2 into 1. 2 into 1. 2 into 2 kada. That is h. Capital H. తర్వాత ఏమొస్తుంది? 2 times of e power 6h and so on up to infinity. And so on up to infinity. And so on up to infinity. Focus here. Focus here. Here. What you will get? What you will get? This is h. ఇక్కడ మనం ఏం చేయాలంటే 2e square h కామన్ చేయాలి. ఏం చేయాలి? 2 times of e square h taken common. Then 1 plus ఇక్కడ ఏమొస్తుంది? e square వస్తుందా? తర్వాత e power 4 వస్తుందా? and so on up to infinity. And so on up to infinity. 2 times of e square h taken common. ఓకేనా? e square h కామన్. ఇక్కడ 1 వస్తుంది. e power 4 కాబట్టి e square. e power 6 కాబట్టి e power 4 వస్తుంది. From up to here we can confidently say that this is infinite GP. Infinite GP. Yes, infinity equal to how much? a by 1 minus r. A equal to first term. R is the common ratio. Is to e square by what? 1 minus e square. 1 minus e square. This is the algebraic sum of the total terms in infinite GP. Infinite GP. That equals to h. That equals to That equivalents to h plus 2 times of e square into h into how much? A by 1 minus r. 1 minus r. Okay now. Then what we will get? H taken out. 1 plus 2 times of e square by 1 minus e square into capital H. Capital H. Here what we will get? 1 plus e square by 1 minus e square into capital H. That is the S total distance traveled by the ball in entire journey of the ball. Total distance traveled by the ball. This is the total distance traveled by the ball. Now coming to total time taken by the ball to travel the distance. Total time taken by the ball to travel the distance. Focus here. Total time taken by the ball. Here to here. Here to here. Now tell me. Total time taken by the ball to travel that particular distance. Write down here. Time taken by the total time. Total time taken. Total time taken by the ball. Total time taken by the ball to travel the distance. Yes, total. To travel this much distance, how much time it will take? Okay, now what is the T total? Here, total time. T total. That equals to how much? First T what is the first? పై నుంచి కిందకి T. మళ్ళీ కింద నుంచి పైకి, పై నుంచి కిందకి. ఏమొస్తుంది ఇక్కడ? 2 times of T1 plus 2 times of T2 plus 2 times of T3 and so on up to infinity. Clear? So that equals to T plus ఇప్పుడే రాసాం కదా Tn equal to how much? E times of T. This is e power n, right? E power n, e power 1 T plus 2 times of e square T plus 2 times of e cube T and so on up to infinity. Clear? Now tell me what you will get. Here T plus 2 times of et taken out. 2 times of et taken out. 1 plus e. 1 plus e plus e square plus and so on up to infinity. 2 times of et. This is how much? 1 plus e plus. This is how much? Infinite GP. Yes, infinity equal to how much? A by 1 minus r. Infinite GP. A by 1 minus r. Then T plus 2 times of et into how much? A by 1 minus r. Then 1 plus 2 times of e by 1 minus e into how much? T. Clear? Then what you will get? 1 plus e by 1 minus e into t. T equal to how much? Square root of 2h by g. That equal to 1 minus e by 1 plus e. Yeah, write down up to here. This is the T total. total time taken by the ball. Total time taken by the ball. Total time taken by the ball to travel that much distance. Now, average speed of the ball. This part completed. Here. This part completed. Here to here. Focus here. What is the total time? Total time equal to how much? Total time equal to how much? 1 plus E by 1 minus E into how much? T equal to how much? Square root of 2h by g. Square root of 2h by g. Here T equal to how much? Square root of 2h by g. 2h by g. T total. This would be T total. Now coming to average speed. Focus here. Now coming to average speed. Average speed. Okay now. So average speed. Average speed of the ball. Average speed of the ball. Average speed of the ball. What is the average speed? V average. Generally, average speed can be written as total distance by total time. Total distance. S total by T total. T total. That equals to how much? 1 plus E square. 1 plus E square by 1 minus E square into H by how much? 1 plus E by 1 minus E into how much? Square root of 2h by g. Square root of 2h by g. Understood? E 1 minus E square lo 1 plus E 1 minus E ఉంటుంది. అప్పుడు ఏమవుతుంది? న్యూమరేటర్ ఏమవుతుంది? ఫోకస్ హియర్. న్యూమరేటర్ ఏమవుతుంది? న్యూమరేటర్ లో ఏమొస్తుంది చెప్పండి? 1 ప్లస్ E స్క్వేర్. ఇక్కడ ఏమొస్తుంది చెప్పు? ఇక్కడ హెచ్ లో రూట్ హెచ్ ఒక రూట్ హెచ్ క్యాన్సిల్ అయిపోయింది. రూట్ జీ పైకి పోతుంది. అప్పుడు ఏమొస్తుంది ఇక్కడ? root gh by how much? Root gh by how much? This 1 minus e cancelled out. E 1 minus e square net right. 1 minus e into 1 plus e right. Appudu e particular 1 minus e 1 minus e cancel అయిపోతుంది. ఈ 1 minus e cancel అయిపోతుంది. డినామినేటర్ లో ఏముంటది? ఒక 1 ప్లస్ ఈ ఉంటుంది. ఆల్రెడీ ఇంకొక 1 ప్లస్ ఈ ఉందా? ఇక్కడ ఆల్రెడీ ఇంకొక 1 ప్లస్ ఈ ఉందా? రూట్ 2 కూడా కింద ఉందా? ఇప్పుడు మనము ఒక రూట్ 2 తో మల్టిప్లై చేసి ఇంకొక రూట్ 2 తో డివైడ్ చేయండి. ఒక రూట్ 2 తో మల్టిప్లై చేసి ఇంకొక రూట్ 2 తో డివైడ్ చేయండి. అప్పుడు ఏమొస్తుంది? న్యూమరేటర్ ఎలా ఉంటుంది? 1 ప్లస్ E square into square root of 2gh by 2 times of 1 plus E whole square. That is the average speed. Understood? Finally, what is the average speed of this? What is the average speed of this ball? Average speed of the ball. See here. Average speed calculations. V average. Average speed equals to 1 plus E square by 1 plus E square by 1 plus E square by 2 times of 1 plus E whole square into square root of 2GH. Square root of 2GH. This is the expression for average speed of the ball. Average speed of the ball. This is all about bouncing of ball cases in collision chapter.